Good morning. My name is Nicholas Ponticus. I am a postdoc at the UCL Institute of Ophthalmology, where I specialize in the genetics of inherited retinal diseases, and a part-time data scientist at Moorfields Eye Hospital, where I specialize in image analysis and AI. My proposal today is the result of 3 years of work at the Institute, and I'm going to be trying to use AI to improve and facilitate the genetic diagnosis of inherited retinal diseases. So the problem we are facing is that finding the genetic diagnosis of an IRD, inherited retinal disease, is difficult. Inherited retinal diseases are typically early onset single gene disorders, and they cause visual impairment in both eyes. Although individually rare, cumulatively they affect around 25,000 individuals in the UK, and they are the leading cause in the working age population of visual impairment. There's many gene therapies being developed at the moment, and this is why genetic diagnosis is extremely relevant. However, the genetic diagnosis process is lengthy, difficult, and costly at the moment. It involves coordination between a lot of specialists, and which individually do not necessarily have the knowledge to look at the data as a whole, and also requires very expensive equipment, which is only available at certain specialist centers such as Moorfields Eye Hospital. However, even at Moorfields Eye Hospital, we are still only getting 40% of our cases diagnosed. So the aims of Eye2Gene are to try and improve the genetic diagnosis rate of IRDs using machine learning, and to build a central resource for patients and doctors to communicate and get involved. The objectives to achieve this are firstly to predict genes from retinal images, secondly to predict genes from clinical symptoms, and thirdly to predict the causal mutation from all the above data plus genetic data. So my first objective, I'll be using 28,000 images at Moorfields, and these are all images which are autofluorescent images, as you can see on the right here, which are labeled with the gene that is thought to cause the disease. So this can be used as training data for the convolutional neural network, and from there we're going to obtain gene probabilities. For one image, we'll be obtaining the probability of that gene causing the disease. The other type of data is going to be the clinical record data. So we're going to be getting all the text data from our electronic health record, and from that we're going to be extracting human phenotype ontology terms, which are standardized clinical vocabulary to describe clinical symptoms. And from these HPO terms, human phenotype ontology terms, we're going to be obtaining genetic probabilities using our prediction model. Finally, we're also going to be integrating the genetic data. We have about 9,000 patients with genetic data at Moorfields. We're going to be feeding that through our UCL genomics pipeline to analyze it, taking into account the HPO terms, and from that we're going to also be able to prioritize genes and obtain gene probabilities. Combining these three outputs, we'll be taking gene probabilities, integrating them into some sort of weighting them according to some framework, and obtaining a gene prediction from this data. This is going to be made available as a web platform where users will be able to contribute their own images, their own clinical symptoms, and genetic data. So the outputs are going to be an efficient genetic diagnosis tool for IRDs. It's going to be the world's largest data set of IRDs through users' contributions from around the world, and it's going to be a portal for patients and doctors to communicate. The data is going to be patient-owned and managed, and in the long run, I'm hoping it's going to preemptively predict IRDs. My training and development plan involves courses in my first year, in clinical ophthalmology, text mining, and image analysis, with strategic research visits in the US, France, Japan, and Germany, key centers to enable data sharing and exchange of learning new skills. And I'll be presenting my work at large conferences in ophthalmology and genetics. Also, of course, attending the public conferences organized by RPFB. And finally, here's some feedback I've received from this side from my idea from patients already, and it's been quite positive, and quite a few patients are interested in getting involved already. Thank you.